Hello everyone, reporting today for First Updates Now, I'm Abbas, and with me here is Team 9527, Rogue Resistance from Cedar Park, Texas. They currently have the Texas state record at 266 points, and were the winning alliance captain at the North Texas Semi-Regional regional tournament, and they have been featured in our FTC Top 25 multiple times this season. So I'm really excited to jump into their robot. It's super compact yet blazingly fast, and I can't wait to see what this team has to say. All that and more coming up on First Updates Now.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. SOLIDWORKS is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow.
Alright guys, let's get started with your drivetrain. It's very unique in the material selection, I think, as well as a bunch of other factors. So give us an overview of it, Seb, and then we'll talk more about it.
Okay, so whenever we were switching from our V1 to our V2, we knew that we wanted to have a much smaller drivetrain, as our V1 was like 16 inches square. But we also knew that would make us more prone to tipping. So in order to prevent tipping, we made the drivetrain have a 1/4-inch steel base plate, as well as 1/4-inch steel outer plates, which gives us a ridiculously low center of gravity and gives us a really good amount of pushing power during teleop.
Yeah, that's fantastic. And so, also, which wheels are you using for your drivetrain? I see they're Mecanums, but correct me if I'm wrong, but those don't look like Go Build a Mecanums.
Yeah, the Go Build Mecanums being 4x4 make it really hard to package on such a small drivetrain, so we're using the Rev Mecanums right now, which have served us really well.
Yeah, and so to give a little bit of context to like everyone watching, you mentioned that you have a V2 robot and then you had a V1. So was it like a complete redesign between these two robots, or was it like some sort of like, was it different?
It's not exactly a complete redesign. For one, the claw module is completely the same between both robots. It's mostly just a optimization, making the slides faster, making the slides draw less current, making the robot smaller and faster to try and make our architecture as competitive as possible.
Mm-hmm. Yeah, that makes complete sense. And so, like, looking back on this, is this something you would recommend to other teams in the future for them to try if they have the time? Or, like, what do you think they need to be aware of? Like, what was very risky, or, like, what would you have done differently if you could go back?
I feel like I would have done the rebuild again, but I would have probably tried to work on both robots in parallel.
Mm-hmm.
It's really nice to be able to just keep the same architecture and know, hey, we're still going to have the same pass-through active claw design, since you can take a lot of elements from from the first version, but rebuilding is always a really big risk. So it's always nice to have your V1 robot ready to go and keep working on it just in case you run out of time for your version 2.
And actually, on that note, just from a software perspective, looking at that, our V1 was very easy to code and go through and everything. But V2 ended up being, it ended up taking a lot more time to actually go through that. So that's something to keep in mind as well.
Yeah, and so I was actually going to ask that as my follow-up question, is like, that's from the hardware standpoint is what we've heard, and now from like a software standpoint, what did the rebuild look like? So thank you for answering that already. And another question I have is, like, from a software standpoint, is there anything that really sticks out to you guys that you think is unique that other teams haven't implemented with regards to their drivetrain and autonomous or teleop that you'd like to talk about?
Yes, definitely. Two things, kind of mainly. So number one is Blacksmith. So it's a library we've created to make creating autonomous and teleop programs more easily. And additionally has some other built-in features that are commonly used. So it kind of extends based off of Roadrunner and makes all of that much easier to implement. And additionally, for teleop, it implements a command-based API. So, which is very simple. Like if A button pressed, lift, go to high, for example. And so just the ability to create autonomous programs, you might be like, well, with Roadrunner, it's easy enough. You don't have to do the math. But yeah, it just makes it a lot faster. So to kind of iterate. The other big thing I would say is we're using Kalman filters, and that just reduces the noise in all of our measurements significantly. And that's also including Blacksmith. So You
Yeah,
should check it
that's
out. You should ask one of us, just anyone who's on 9527 can point you to the resource.
Yeah, no, that's fantastic. And, there's just so much going on in this robot that we have to move on to the next subsystem. So let's talk about your intake. Every single part of this robot is so unique and innovative, but this is definitely something that really sticks out. So walk us through it, any iterations you've had, and how it is today.
We've never really done much iterating on it. We kind of just over designed it in the first place, and it hasn't really had any problems. Basically, when we had kickoff, we wanted to maintain that philosophy of touch it, own it for the cones, because we noticed a lot of teams are going kind of to claws, which aren't exactly active intakes; they're more so passive. So we decided to have an active intake claw that allows to intake the cones in under half a second. The way it works is that we have an Axon mini servo geared like 5-to-1 at this point on these custom red compliant wheels. I want to show a little closer. Put a forward intake. So we have these custom compliant wheels attached to a bunch of polycarbonate construction. It's just a bunch of zombie axling inside. So it's nice and compact. Very complicated, but it's been one of the more reliable parts of our robot, ironically.
Yeah, and so you mentioned that it's a 5-to-1 gear ratio now for that Axon Mini. So is that something that you changed throughout the season?
Originally, we had it 1-to-1 off a speed servo, and I would honestly say that was worse than a regular claw. Then we switched to 2-to-1 off a speed servo, which is actually pretty nice. And then finally, we got the really big reduction off the Axon servo, and that has just been lovely to work with during teleop.
Sure. And so you mentioned you have these like custom silicone wheels. So can you delve into that a little bit more, like how you made those, and if there's any resources for teams to do the same?
So we actually released these under open mold. I can probably send a link later. It's been a while. These are custom silicone molded wheels. The reason we made them was one, because we weren't really liking the mounting options for the silicone AnyMark compliance, and those are TPU instead of silicone, so they're actually less grippy. And two, we wanted to have a custom color for them. So you can actually make these really any color. I use just red dye. I've made these out of orange, black. I've had teams make these blue. There's a lot of options for it, and they're actually pretty cheap too. But they've been really nice.
Yeah, that's fantastic. And so let's talk about the programming behind this arm a little bit. Before we jump into like the algorithms and automations you have specifically, talk a little bit about how it's powered, like what servos and or motors you have going into your claw, and then let's talk about the automations.
We started off with two. Could you go to low probably?
Sure.
Or mid?
Yeah.
So we started off with two motors. With not two motors, one motor on the actual arm in our V1, which was really heavy. So then we switched to two Axon servos plus a counterspring, which makes this thing blazingly fast. Like if you go to deposit, this thing will move in a very quick period of time.
It's just snappy.
Yeah.
And so you have two servos, two Axon servos to pivot the arm, and then one for the wheels, like for the active portion of the claw, one for the actual claw part of the claw, and then another for a wrist. Like, is it 5 servos total, or how many is it?
Yeah, it's a five. It's a piece of work. There's a lot of servos on it. Only 3 of them are Axons because we determined that running go build a speed servos on the other applications was perfectly fine. But yeah, it's a lot of servos.
Okay, yeah, and so, yeah, let's jump into the software for that now. Talk a little bit about the automations you guys have. I mean, we've seen a couple one-button presses seem to be able to do everything just on screen here, but I'm sure you can definitely tell us more.
Yeah, so with the command-based API that we've implemented, it becomes very easy to just chain together a series of sequences. So for example, all we have to do is press the left trigger to go down to intaking. That'll start the intake wheels. And then we have actually a color sensor, which is also a distance sensor since it's a Rev 1. And it will automatically stop the wheels when a cone has been intaked, so we don't strip out those gears, and then release the button, and it goes to the resting position. Then we have just some preset using the D-pad. We have some preset positions for mid, low, or high. And and so then we just press the right trigger and then release it. Well,
yeah, there's no junction there. That's fine.
But and then we just release the button. And so the whole idea is to make things as easy as possible for the drivers so that they can just focus on strategy, because this is a really important game for that.
For
sure.
Sure.
Just making everything as easy as possible. And yeah.
Yeah, and speaking of strategy, why don't we talk about that a little bit before we go on to your guys' lift. So in general, what does your guys' game strategy look like, and how do you adapt it to work with different teams?
So at the beginning of the season, our strategy was basically the same. It was circuit building because we didn't have a lot of like experience within the game sense.
Hmm.
So at the beginning, we just kind of went for circuit building and tried getting that points for just ownership of those circuit ones. But as the year went on, I've kind of had it to where we've done more ownership and circuit. So we've just had tried controlling the field over the like just in general. And usually whenever before like our matches, I talk to the our alliance member and we try getting a general strategy. Like sometimes it'd be like one of us does ownership while another does like putting ground junctions or does like the circuit building part of it, and putting cones in the triangles and all of that.
Hmm.
But in general, it's just been over the year I've done a lot more for the strategy part of it for our drive team.
Sure. And so going into your lift now, let's talk about the hardware first. There's just so many fantastic things to talk about here. So please give us an overview.
This is one of the more complicated mechanisms we've designed in our time. So on our V1, we started out with just standard Masumi slides with our wheel claw and everything, but that was ridiculously heavy, somewhere around 6 pounds. We've lightened it up since then. It's like down to 5, I believe now. But it took a lot of work, and it took 3 motors to lift this thing in about 1.5 seconds to 2 seconds, which we were really unsatisfied with. And for V2, since we want to go smaller, we knew that basically having a 3 motor lift and being small was basically like an antithesis to itself.
Yeah.
So we knew we needed to have one something to either have to make the lift lighter for regular claw, or find out some other way to make the lift faster. Well, we did some research and found that in FRC, a lot of teams will use constant force springs, as shown here, which are basically just like springs that have a constant force that like unravel themselves and can go up and down to effectively counterspring their lift and basically fight the force of gravity. Well, you're still fighting inertia, but the actual force of gravity is negligible. So we've implemented it on this lift. We string it in cascade, so all those stages extend at the same time. And we move, and we have 2 constant force springs, which basically negate the force of gravity. So this lift will just stay anywhere you put it. Gravity is a non-issue. And we can actually run the entire lift off of a single motor, and it's blazingly fast. It's about half a second all the way up to high.
Wow, yeah, that's just incredible. And another thing I want to ask about is, so you guys said you're running your lift off of a single motor. So if I'm counting right, that means you guys have 5 motors total for your robot, and then as well as 5 servos, or do you have more servos elsewhere?
That's all of our actuators.
Okay,
We
so
also have one servo on the front for a camera. We
uh-huh.
were messing around with a rotating camera, but we haven't really used it much.
So my question there being is, are you guys using 2 hubs, or is it like just one hub and you've been able to fit everything on it?
We actually only have a single hub on this robot, plus a Spark Mini to drive the last motor, which is just tucked in there in a custom channel.
Hmm.
Um, but we've made this as compact as possible. But we knew that after some discussion, we knew that a second hub was basically out of the question. So we managed to get our hands on a Spark Mini because one of our members had one from a personal project. Thank you, Tiernan. And that allows us to drive all of our motors and servos off of a single hub, which has been absolutely wonderful for current draw and for loop times, I believe, as well.
Yeah, no, that's awesome. And so, looking forward to your next competitions, Texas is definitely one of the most difficult regions to advance out of, and I'm sure, being the current state record holders in Texas, you would like a slot to the Houston World Championship. What will you guys have to do to make that happen, right? Like, what's stopping you guys from doing that currently, or is it just sort of continuing the same path you have been doing, just driver practice, and autonomous?
We, yeah, we're basically at the point where the only things we really can do is driver practice and autonomous. I feel we finished up the all hardware modifications for this next for our regional championship.
Hmm.
So right now we're just focused on getting the auto working, getting the auto consistent, and getting Angel practicing with the drivers as much as possible.
We have a
Yeah.
very consistent 1+5 auto on mid, but with all the cones being posited on mid, it would be very nice to, we're working for a high auto as well. We'll see. Those poles are just a lot more bent, and so it becomes more unreliable. And we've also had some issues with localization on the smaller drivetrain inaccuracies and such.
Hmm.
Uh,
Yeah,
yeah,
no,
that's what we're
you've just been reading my mind this whole interview. I was just gonna ask, how's your autonomous looking? Do you have any plans to change it at all for future competitions? But overall, Rogue Resistance, this has been just an absolutely fantastic interview. Your guys' robot is so incredible, and I'm really glad we can show everyone in the community how much there is to take away from this. So I hope to see you guys on many fun top 25s in the future, and hopefully at the Houston World Championship as well. So thank you, Rogue Resistance, very much for this interview. Reporting for First Updates Now, I'm Abbas.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. SOLIDWORKS is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. Check out our all-new FTC content coming to Fun's YouTube, including new hosts from the FTC community. We'll have resource guides, top 10 moments, behind the bots interviews, and walkthroughs to help your FTC team improve at youtube.com/firstupdatesnow. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.